Okay, so let's move on. Let's talk about right triangle trigonometry. I know we've been talking about it already, but let's look at this particular triangle and see what we can do to find the missing angle and the missing sides, okay? So, I'm missing one angle and I'm missing two sides. Now, I don't know about you, but I do remember one thing about the three angles of a triangle. They always add up to, excellent, 180 degrees, which means if I take my unknown angle of alpha, add it to 17 degrees, add it to the 90-degree right angle, that should be 180 degrees. Yes? Okay, so when all is said and done, alpha would be equal to 73 degrees. Cool? Good. So we know this angle, it's 73 degrees. Loving it. Now, I still am missing side A and side C. The one thing I do know is that the 3 that I do know for this side is opposite that 17-degree angle, isn't it? Okay, so that leads me to two trig functions. What are they? Sine, excellent, as well as tangent, great. Now, depending on which side you would like to find first, either A or C, depends on the trig function. So, I want to find side C first, and C is clearly the hypotenuse. Do you agree? So now let's think about it. I've got an angle, and I know the side opposite the angle, and I'm looking for the hypotenuse. So I'm dealing with an opposite side and a hypotenuse. Which trig function is that? Good, sine, because the sine of an angle is equal to the opposite side over the hypotenuse. So in this case, I would have the sine of 17 degrees would be equal to 3, which is the opposite side, over C, which is my hypotenuse and the side I'm looking for. Okay, so this is pure algebra from here. You're solving for C, but we don't like it in the denominator, so multiply both sides by it, right? And then divide by the sine of 17 degrees to get the C by itself. Good? Okay. And then if they ask you to give them 1 decimal place, 2 decimal places, whatever, you can punch that into the calculator yourselves and figure it out. But please remember, make sure your calculator's in degree mode, right? Okay, so side C we found. We still need to find side A. So, now let's take a look. Again, I'm sticking with the 17 degrees. Why? Because if I messed up on 73 degrees, I'm going to mess up on finding A. So, and I would have messed up on finding C also, which is why I always want to stick as much as I can with the angle they gave me. So now 3 is opposite the 17 degrees, and the side I'm looking for is adjacent, isn't it? Opposite side, adjacent side. Which trig function? Good, tangent, because tangent of an angle is the opposite side over the adjacent side, which means I would have the tangent of 17 degrees being equal to the opposite side, which is 3, over the adjacent side, which is A. Algebra, got to solve for A, don't want it in the denominator, multiply both sides by it, and get rid of the tangent of 17 degrees to get A by itself. Cool? Okay, and again, depending how many decimal places they want, you can just punch that into the calculator and figure it out. But please, again, be very aware your calculator needs to be in degree mode in order to do that correctly. Cool? Okay, loving it. Stay tuned, we've got some applications. Okay, so let's talk about some applications with respect to our right angles trigonometry. Right triangles, basically. They've given us this picture, and it's the picture of a canyon, basically. And they're asking us to find the distance from A to C. okay? Across the gorge. And we clearly see that there is a chasm there, so it's a gorge. Now, here's the deal. We know that we've got a right triangle, because there's the right angle, and some of you may be going, but they didn't say it was a right angle. This is a right angle in this particular case. And you're right, they should have actually been a little more explicit, and they weren't. So I'm sorry that they weren't, but this is definitely a right angle, and we're finding the distance from A to C. So here's the deal. When you deal with a right triangle, there's two things that you can work with. You can either work with the Pythagorean theorem, or you can work with the trig part of it. So here's the deal. If you're going to work with Pythagorean theorem, you need at least to know two sides of the triangle to find a third side, correct? Okay, I only see one side, 160 feet. I don't see the length of any other side. So Pythagorean theorem in this case is out the door, which means I got to deal with some trig. So let's do some work on the next page. Make sure we're all, you and I are on the same page. So let me redraw our triangle. This was a 20-degree angle. This was 160 feet. Yep, in feet. And by the way, notice it says do not round until the final answer, and then they want 2 decimal places. So here's the deal. Right here is our missing side. This is our missing side. This is what we need to know. This is the distance across the gorge. And we can call it anything we want. I'm just going to call it GYG because G stands for gorge. How's that? So we need to know the pieces to our puzzle. We have an angle of 20 degrees. Now, look at the sides they've given us. They gave us this side of 160. That 160, where is it in relation to the 20-degree angle? It's next to it, isn't it? So since it's next to it, this would be considered the adjacent side. Look at G. G is located where with respect to the 20-degree angle? It's located opposite, so G would be considered the opposite side. So my question to you is this. Which trig function deals with an adjacent side and an opposite side? Yeah, you've got 2 choices. You've got tangent or cotangent, don't you? So it doesn't really matter. I always go for tangent. Why? Because my calculator actually has tangent on it versus cotangent. So I am going to set up with respect to tangent. So the tangent of theta is going to be equal to the opposite side over the adjacent side, correct? So my angle is 20 degrees. My opposite side, I have no idea, we called it G. My adjacent side is 160. To get the G by itself, multiply both sides by 160. Do you agree? Okay. Now it's time to do some calculator work. So we're going to take the tangent of a 20-degree angle, and we get to multiply by 160. Hopefully your answer is the same as mine. We get 58.2 approximately. And our answer is in feet. So the length of the gorge is approximately 58 2/10 feet wide. Cool? Okay. Let's go to another one. Looks like we have the Toy Eiffel, also known as the Eiffel Tower. And it wants you to find the height of this tower using the given information. So notice what information it gave you. It gave you from the middle to the end of a foot is 60 feet. It also gave you this angle right here. And they said this angle wasn't too clear in the picture. It was 85.886 degrees. And they said to find the height of this tower. So I don't know about you, but you know what it looks like they drew to me? Yep, looks like they drew a right triangle to me also, which means I have two possible ways of taking care of a right triangle. I can either use Pythagorean theorem or I can use trig. So remember, to use Pythagorean theorem, I need to know at least two sides. I only have the one side of 60 feet. I don't know any other side, so I don't think Pythagorean theorem is going to work for us. So, got to go with trig. Now, I'm going to redraw this on our next page because our next page has a little more room for us to work. Again, do not round to the final answer, and then they want to round to 2 decimal places. So, here's 60 feet. There's our right angle. This is 85.886 degrees, and they want to know the height of this tower. Okay, so just like we did before, we need to understand what information they gave us with respect to this angle. Because if I know the sides and where they are in relation to the angle, then I know which trig function I'm supposed to use. So, the 60 feet is right next to this angle, isn't it? So that's my adjacent side. The height is opposite the angle. So that's my opposite side, which means I'm dealing with which trig function? Yep, I'm dealing with tangent again. So to find the tangent of an angle, we take the opposite side over the adjacent side. So in this case, we're taking the tangent of 85.886 degrees. By the way, please make sure your calculator is in degree mode for the last problem and this problem, because if it's not, you're going to get a different answer than myself. The opposite side, which we're going to call h for height, over that 60 feet. Get h by itself, which means I have to multiply both sides by 60. And then we've got some calculator work to do, don't we? So you get on your calculator, I'll get on my calculator, and hopefully we get the exact same answer, right? Because if we don't, one of us is doing something wrong. And this is why I always want you working stuff out with me, because, you know, I am human. So I got 834.18 feet is approximately the height of this tower. What do you think? So far, so good? Okay, let's try another one. Suppose that you're headed towards a plateau 50 meters high. If the angle of elevation to the top of the plateau is 25 degrees, how far away are you from the base of the plateau? Okay, so me personally, I need a picture. Here's my plateau. Right, if you don't know what a plateau is, it's basically a flat piece with a drop off. Okay, it's like a sheer drop off. And you're headed to the plateau. By the way, they say this plateau is 50 meters high. Okay, you're heading to this plateau. So let me get you drawn in here. There you are. You're walking towards the plateau. And it says the angle of elevation to the top of the plateau. Elevation, which means we're looking up. They said it was 25 degrees. And they want to know how far are you from the base of the plateau. They want to know this distance. Does that make sense? Okay, so once again, by the way, since this is a sheer drop-off, that is a right angle, isn't it? So once again, I've got a right triangle, and I have to choose between Pythagorean theorem or using one of my trig functions. and I only know one side of that right triangle. I don't know two of them, I only know one of them, which means we can't use Pythagorean's theorem. So let's go do some work on the next page. We know this side is 50 meters. We know this angle is 25 degrees. And this is the side they want us to find, right? Okay, so just like we have been doing, we need to see what information we have. This unknown side is next to that 25 degrees, isn't it? So that's our adjacent side. This 50 meters happens to be opposite, correct? Which means, once again, we are dealing with which trig function? Good, tangent. Are we always dealing with tangent? Not always, but you know, in a lot of these cases, it is going to be tangent if we're dealing with adjacent sides and opposite sides, right? So tangent is opposite over adjacent. I'm talking about the tangent of a 25-degree angle. My opposite side is 50. My adjacent side, that was the base, wasn't it? I have no idea what that is, do I? So it looks like we've got some algebra to do because we can't have, first off, our variable in the denominator, and secondly, I'd rather not deal with the denominator if I don't have to. So I'm going to multiply both sides by the b, and then I need to get b by itself, so now we have to divide both sides by the tangent of 25 degrees, don't we? Okay. So, looks like we got some calculator work to do. Once again, please remember to always make certain your calculator is in the correct mode, either degree or radians, and please make certain you use parentheses where appropriate. So, I'm waiting. Did you get your answer? Because I certainly got mine. All right, so we're going to try it again. Got it? I'm waiting. Okay, this is what I got. Rounded to 2 decimal places. And this answer is in meters. So we are 107.23 meters away from this plateau. That's going to be this length right here with us over here, stick figure. Good? Okay, loving it. Ready for another one? All right, let's take a look at this. A building that is 120 feet tall casts a shadow that's 30 feet long. They want to know what is the angle of elevation of the sun. I don't know about you, but I'm drawing myself a picture. I have a building. There's this window. Need a door to go inside. And it's 120 feet tall. It casts a shadow. There's the shadow. That's 30 feet long. And they want to know what is the angle of elevation of the sun. Well, where's our sun? Yeah, the sun's over here, isn't it? Right? So I'm trying to figure out this angle of elevation right here. What's my angle of elevation toward the sun? So I'm hoping the building is standing up nice, straight, and tall. Because if it's not going to stand very long, which means that would be a right angle, wouldn't it? So again, I've got a right triangle. I can deal with Pythagorean's theorem, or I can deal with trig. Now in this particular case, I have two sides of the triangle, don't I? Which means I could deal with Pythagorean's theorem, couldn't I? But question, do they want the third side? No, this is not what they're looking for. They're actually looking for an angle, which means Pythagorean's theorem is still not going to work for us. Also, by the way, they're looking for degrees. So please make certain your calculator is in degree mode. And they want the nearest tenth of a degree in this case. So let's go ahead and redraw this over here. Let's see what we got to do. And clearly my drawing is not to scale. So we have 120 there at the height of the building. We have 30 feet at the base. And this is my theta. because theta's got to be that angle of elevation, right? All right, so here we go again. The question I have is this. What is the relationship between this side and this angle? Yep, that's the adjacent side, and the 120, that's the opposite side. So once again, I'm dealing with tangent, which is opposite over adjacent, which means the tangent of theta, I don't know what theta is, will be 30 divided by 120, correct? And that looks like it's going to reduce pretty nicely, don't you think? 30 divided by 120 is, yep, you said it, 0.25. And now I have got to get theta by itself, because that's my unknown, isn't it? So to get theta by itself, I got to get rid of tangent, which means you have to take the tan inverse of both sides, don't you? Which leaves theta equaling the tan inverse of 0.25. Please make certain your calculator is in degree mode, because if it's not in degree mode, you're not going to get the same answer I'm getting or your neighbor is getting. I end up with theta being approximately 14.0 degrees. What do you think? Do you agree with me? Loving it. Okay, let's see what else we got. A security camera in a neighborhood bank is mounted on a wall that's 10 feet above the floor. The question is, what angle of depression should be used if the camera is to be directed to a spot 5 feet above the floor and 15 feet from the wall? Okay, so this is kind of interesting. I'm thinking I need a picture, don't you? All right, so we got a bank. Here's our bank. And the security camera is mounted on a wall 10 feet above the floor. So this looks like it's 10 feet. And my camera is right here. And I don't know how good of a camera drawer you are, but it's mounted. So there's my camera. Clearly looking down, making sure that no one wanted to come near. They want the angle of depression. If the camera is to be directed to a spot 5 feet above the floor and 15 feet from the wall. Okay, so hold on a second. Here's my wall. So we're supposed to be 15 feet away. Okay? And the interesting thing it said was they want the camera to be directed to a spot 5 feet above the floor. If this is my floor, the camera is supposed to be 5 feet above the floor, which means my camera is supposed to be looking right here, kind of at somebody's head, isn't it? And they want an angle of depression. Depression means it's going down, isn't it? So here's the deal. This angle is the angle of depression because it is going down. This camera is looking down. This camera is looking down to this spot right here. So I do still have a right triangle. I'm looking for this angle. I have no idea what it is, right? But if I'm looking for the angle, I need to know a couple of sides. Can you identify one of the sides of that orange triangle? That's good. So this top is 15 feet because it mirrors the floor, doesn't it? And this side would be 5 feet, wouldn't it? Because I got a 10 feet wall and the camera is looking at 5 feet above the ground, isn't it? Good. We do okay with this? Is this making sense? All right. So I think I have room here to work. So I'm just going to redraw this triangle. This is my theta, my unknown. This is 15, and here is 5. So once again, I need to know I actually have more room to work. Once again, I need to know what positions these two numbers hold. And I think you're getting the hang by now. This side is adjacent to theta. This side is opposite from theta. So once again, we are dealing with tangent. Again, that doesn't always happen, but you know, tangent comes in handy when you're looking at things across from you and things next to you. So I'm setting it up opposite over adjacent, right? And let me get rid of that. And this fraction is not going to be in a decimal very nicely, so I'm going to leave it as a fraction of 1/3. But once again, to get theta by itself, you're going to have to take the tan inverse, aren't you? Good. So when you take the tan inverse, you are simply going to be left with theta equaling the tan inverse of this fraction 1/3. Cool? That makes sense? Okay, again, they want it in degrees, so please make certain your calculator is in degree mode, because if it's not in degree mode, we're going to have a challenge. And I believe they said 1 decimal place. So I have the angle of depression to be about 18.4 degrees. Did you get the same? Lovely. How are we doing? We all right? Cool. Okay, so let's take a look at this problem. This will be our last one we're going to work on. So question. Well, let's read the question, I should say. A state trooper is hidden 30 feet from a highway. See the drawing? He's trying to catch this guy, right? Trying to see if this guy is speeding or not. So here's our state trooper. He's 30 feet from the highway. 1 second after the truck passes. This is 1 second. The angle theta between the highway and the line of observation to this patrol car is measured. So here it is. They're saying if the angle measures 15 degrees, they want to know how fast is this truck actually traveling. And they would like your answer in feet per second, and they also want it in miles per hour. So hang in there a second. Let's do one thing at a time, right? I have, and I'm going to draw on the next page. I have my highway patrolman here, right? Here is our highway patrolman. Oops. Here is our truck. Here is at 15 degrees it told me. Here is 30 feet. They told me this was 1 second, didn't they? Well, that's fine. That's 1 second. And by the way, there's a right angle, isn't it? So, question for you. Since they want speed, when you look at your own car speedometer and you say how fast you're going, you would say something like 50 miles per hour, wouldn't you? You would have a distance over time, wouldn't you? Okay. So here's what I know. From where the officer actually saw the truck, which was right here, to where the truck is actually now at this particular point, I know that's 1 second. But, and there's my time. I know my time is 1 second. What I don't know is in that 1 second, how far that truck traveled. You with me? I know how long it took him to get there, but what I don't know is how far he traveled in that time. If I knew how far he traveled in that time, then I could find the speed, couldn't I? All right, so here's the deal. This is what I'm looking for. I'm actually looking for this distance. Once again, here's my angle. This is opposite the 30 feet. My distance, which I don't know, is the adjacent side, isn't it? Once again, what are we using? Yeah, we're using tangent. So the tangent of 15 degrees would equal my opposite side over my adjacent side. So that's the distance I'm looking for. Remember, it's a distance you're looking for. So getting rid of that denominator, getting the d by itself. Make sure your calculator is in degree mode so that this will work out correctly. Because if it's not in degree mode, this isn't going to work out. And I have approximately 112 feet. So that means, let me write it here, 112 feet. So that means the speed of this truck is 112 feet in 1 second. They did ask me to find the speed in feet per second, didn't they? But here's the deal. Not only did they ask me to find the speed in feet per second, they also want it in miles per hour. So I've got some converting to do. I need to take 112 feet over 1 second, and I need to convert it into miles per hour. Now, here's a technique I learned when I was in high school chemistry class, and I never forgot it because it's not based on numbers, though I do need to know the numbers. It's all based on me putting my units in the correct spot. I know there are 60 seconds in 1 minute. And you're like, why'd you put the seconds on top? I put the seconds on top so I could cancel the seconds on the bottom. Got it? And now I'm in feet per minute, but I don't want minute. I want hours. So I know there's 60 minutes in 1 hour. Why'd you put the 60 minutes on top? So I could cancel the 60 minutes on the bottom. Now I got feet per hour. Okay, that's good because I'm supposed to have hour in the denominator, and I do have hours in the denominator. So this, check. I've got the hours in the denominator. We're good. But feet can't be here because it's supposed to be in miles, which means I need a conversion between feet and miles. And some of you may know it and some of you may not. Your conversion is 5,280 feet are in a single mile. And why did I put feet on the bottom? Yeah, to cancel the feet on the top. Now I've got 1 mile, now I've got miles on the top, which is what I wanted. This conversion technique is very simple. I put the units where I need them so I can cancel the other units. I put miles on the bottom, miles on the top and feet on the bottom so I could cancel the other feet that were on the top. Cool? All right. Now I know what to do between my numbers. I simply have to multiply these 3 numbers together. And I know this will be miles. And I have to divide by this 5,280. And I know that will be hours. So you do your work. I'll do my work. Hopefully, we end up with the same answer. I have got, if I round to the nearest tenth, 76.4 miles per hour. And we're better known to us as mph, right? Either way, it's fine. That truck's going pretty fast, don't you think? I think that truck might get a ticket. Anyway, hopefully this made sense to you. Watch it as many times as you need to. That's the advantage of having a video, and I'll catch you on the flip side.
Bye.
Okay, so let's talk about one more set of identities, known as cofunction identities. Over here I've drawn our 30, 60, 90 degree triangle, and what I'd like us to look at is this. I'd like us to find the sine of a 30 degree angle. Now sine is equal to opposite over hypotenuse, right? Well, if I take a look at that, opposite over hypotenuse would give me 1/2, wouldn't it? Good. I'd also like to look at the cosine of the 60 degree angle. And cosine is equal to adjacent over hypotenuse, isn't it? Which would give me 1/2. So, interestingly enough, I looked at two different trig functions in two different angles and I got the exact same values, didn't I? One thing I'd like you to notice, 30 degree and a 60 degree angle are actually what kind of angles? Think geometry days, starts with a C. Cofunction starts with a C. The word you're looking for these two angles also starts with a C. I think some of you may have said it. These angles are, there it is, complementary angles. When I'm dealing with complementary angles, I need to think cofunction identities because that's how I get to simplify some of these problems they give me using cofunction identities. So let's write some of these identities on the board. One of them we've already figured out. We've already written that the sine of an angle is equal to the cosine of its complement, right? Well, remember, complement means they add up to 90 degrees, which means if I took 90 degrees and minus this angle, that would be the complement, wouldn't it? And by the same token, if I did the cosine, it would be equal to the sine of the complement. Cool? You with me? Okay. Let's look at what's the reciprocal of sine? Good, cosecant. So if I look at the cosecant of an angle, it should be equal to the, what's the reciprocal of cosine? Good, secant. It will be equal to the secant of its complement. And this one, that would be the, that's right, secant of theta equaling to the, good, cosecant of the complement. Good? Okay, let's talk about tangent and cotangent. So the tangent of an angle would be equal to the cotangent of its complement, and vice versa. These cofunction identities are extremely nice because as long as the angles are complementary, I can use these cofunction identities. Now be very aware, sine and cosine go together, their reciprocals go together, and tan and cotan go together. Cool? Okay, hang in there, I'll be back with some examples. Okay, so we're back. Now look at these directions. They ask us to simplify without a calculator. So let's look at the first problem. We're asked to subtract the sine of 82 degrees minus the cosine of 8 degrees. Now, neither one of those are angles that are typical to us. Our typical angles are the 30 degrees, the 45 degrees, the 60 degrees, and the 90 degrees. Because I can draw a triangle with those, I can look at my circle with those, and I can very easily find the values without using my calculator. But with the sine of an 82 degrees or an 8 degree angle, neither one of those are typical angles. So neither one of them work very well for us. Now, here's the one thing I'm noticing though. I'm noticing that 82 degrees and 8 degrees are what kind of angles? Good, they're complementary angles. And since they're complementary angles, that means I'm going to look at the, cofunction identities. Now, this one involves sine and cosine. So, remember, and it doesn't matter which trig function I look at, the sine or the cosine, it doesn't matter. I'm just going to look at the sine. Why? Because it's written first. So, the sine of an angle is equal to the cosine of its complement, isn't it? Well, if I have the sine of an 82-degree angle, that means it's equal to the cosine of 90 degrees minus 82 degrees. Are you with me? Which means the sine of 82 degrees would be equal to the cosine of, that's right, 8 degrees. Which means back over here, instead of saying sine of 82 degrees, I can substitute in cosine of 8 degrees. So I can say the cosine of 8 degrees minus the cosine of 8 degrees. That would just give me 0. All done without a calculator, but I need to remember that I'm dealing with complementary angles, which is going to help me use those cofunction identities. Cool? Okay, let's look at the second problem. The second problem, we're trying to divide two trig functions. And again, 31 degrees and 59 degrees, yeah, those aren't typical angles. But they are complementary, aren't they? All right, which means I need to switch only one of them. If I switch them both, I'm going to be back in the same boat in terms of two different angles. So in this particular case, I'm going to go for the cosine. Why? Why not? In the last problem, I switched the sine around. So in this case, I'm going to switch the cosine around. So the cosine of an angle is equal to the sine of the complementary angle. And in this case, the cosine of 59 degrees is going to be equal to the sine of 90 degrees minus 59 degrees, which equals the cosine of 59 degrees being equal to the sine of, good, 31 degrees. Does that make sense? So back over here, I can make a substitution. I have the sine of 31 degrees in the numerator, and you just told us, we just told ourselves, that the cosine of 59 degrees is equal to the sine of 31 degrees. Excellent. Which means in this case, I simply get a 1. Remember, complementary angles tell me to look at the cofunction identities. And I get very nice, simple answers, all because I realize that they're complementary angles. Cool? Okay, hopefully this helps. I'll catch you on the flip side.